Welcome to JD's Prep. In this question, we're given a table that shows different donor categories and methods of donations for a fundraiser. For the first part of the question, we're trying to find the probability that if we were to randomly select a donor, being categorized as a supporter, given that the donation was made online. So the online donations are these two numbers here, and we can see that 1,200 of them were supporters. So 1,200 out of the total number of online donations will get us our probability. So by adding those two, we get 3,216. So the probability that the online donation was from a supporter would be 1,200 over 3,216, which works out to 0.373, rounding to the nearest thousands. For the second part of this question, we want to determine if the data indicates that being a supporter is independent of donating online. When we're dealing with two independent events, there's some different statements we can say that are true. One you might be the most familiar with is that the probability of both A and B is going to be equal to the probability of A multiplied by the probability of B. Another statement we can utilize here that's going to save us some time is that the probability of A given B will be equal to just the probability of A if the two events are independent. Now, the reason we're going to use this to prove that these are two independent events, or at least test to see that they are, is that we've already calculated the probability of A given B. That was part one of the question here. We were asked to find, given that the donation was made online, that's given B, what's the probability that the donor was a supporter? So this being the donor being a supporter is our event A, and then the donation being made online is event B. So we calculated that already as 0.373. If we can show that that's the same thing as just the probability of A being the probability that the donor is a supporter, then we've proven that these are two independent events. So let's go ahead and test that out. The probability of A, in other words, the probability that the person we're picking is a supporter, we can find by taking the total number of supporters, which is 1,600, and dividing it by the total number of donors. If we add all four of those numbers up together, we get 4,288. And if you work that out on your calculator, you'll see that we do indeed get the exact same probability, 0.373. So for our justification, we can conclude that these events are independent since the probability of A given B is equal to the probability of A. Thanks for using JD's Prep.